Welcome back to my YouTube channel Leon Crackers for cracking IIT and NEET. So in the last video we have discussed how to balance a redox reaction by using few examples only. So in this video we are going to discuss the same concept with few more examples. Then you will be able to balance any kind of redox reaction. So again I am telling the rules and regulations, how points to be remembered while balancing the redox reaction. What is the first point? So write down the separate equations, oxidation and reduction reaction separately. The second point, what is the second point? So balance the number of atoms which oxidation number is changed. And third point, add proper number of electrons to the higher oxidation side. And next one, balance oxygen atoms by adding water molecules. And the next one, balance number of hydrogen atoms by adding H plus ions. After this one, so we have to do this separately, oxidation side separately and reduction side separately. After that, balance number of electrons on both sides. So add these two equations, that will be the final redox balancing equation, right? So now in this video first I am going to discuss with one disproportionation reaction. So chlorine gets disproportionated like Cl2 to Cl minus and ClO3 minus in basic medium. So balance the redox reaction in basic medium. The first point is what is the oxidation state here? 0. Of course only single chlorine atom we have to find. So chlorine atom oxidation state is 0. And 0 to here, what is the chlorine oxidation state? -1. Here this is the compound charge is -1. Then you can find x minus 6 equals to -1. Then x equals to +5. So what is the chlorine oxidation state here? +5. 0 to -1, one kind of reaction. So what is the reaction? 0 to -1, addition of electrons, that is reduction reaction. Next 0 to +5, removal of electrons, that is oxidation reaction. First, what is the point? So reduction reaction and oxidation reaction. So we have to write the separate equations, reduction reaction and oxidation reaction. The reduction reaction is what? Cl2 and Cl minus. Cl2 to Cl minus. Second point is what? So balance the number of atoms which oxidation number is changed. Here 2 chlorine atoms, here only 1 chlorine atom is there. That's why we have to balance this number of atoms. After this number of atoms 2 and 2, we should make the same 2x, right? So what is the 2x here? 2x equals to 0. Next here 2x equals to -2. 0 to -2, what happened? Addition of electrons. Of course this reaction is what? Reduction reaction. So addition of 2 electrons. After that there is no further addition of balancing oxygen atoms and hydrogen atoms because there are no other atoms are there. Leave this equation. And coming to the oxidation side. So oxidation side, what is the equation? Cl converts to ClO3 minus. Here also same 2 chlorine atoms, but we have only 1 chlorine atom here. So it should be multiplied by 2. Then we can get 2x equals to 0. Here what is the equation? 2x. 1 chlorine atom, what is the oxidation state? +5. If you take one molecule, in the one molecule we have x equals to +5, but we are taking 2 molecules, 2 ions. So 2x equals to, what is the equation? +10. 2x equals to +10. 0 to +10, so difference would be 10 electrons to the higher oxidation side we have to add. So 10 electrons to be removed. So what is the reaction? Oxidation reaction. After this, add number of water molecules. Add number of water molecules by balancing, we have to balance the oxygen atoms. So how many oxygen atoms are there? 6 oxygen atoms are there. So that's why 6 H2O. After this, how many H plus? Here no hydrogen atoms are there, but left side we have 12 hydrogen atoms. So we have to add the 12 H plus ions. And up to this one is over. We have to balance separately like this. After this, balance the number of electrons in both reactions. Balance the number of electrons in both reactions. So left side reduction reaction we have only 2 electrons, and right side oxidation reaction we have 10 electrons. Suppose if it seems to be first equation and this is the second equation. So 1 into 5 we may get 10 electrons. So that's why equation 1 into 5. Equation 1 into 5. So 10 electrons plus 5 Cl2 and giving 10 Cl minus. So second equation is as it is. Second equation is as it is. 6H2O plus Cl2 and giving 2ClO3 minus plus 10 electrons plus 12H plus ions plus 12H plus ions. So 10 electrons get cancelled each other, I mean both sides. So we make it, what is the resultant equation? 6H2O plus 5Cl2 plus 1Cl2, 6Cl2 and here 10Cl minus plus here 2ClO3 minus and rest is 12H plus ions, 12H plus ions. And do one thing, this is only, what is the medium here? Acidic medium only, but the question is about in basic medium. In basic medium I told you already, so same number of OH would be added on both sides. If we add here 12 hydroxy, 12 OH minus on both sides, 12 OH minus, so 12H plus 12 OH minus becoming 12 molecules of water. So here 6 molecules, from here 6 molecules get cancelled and we are getting here 6 molecules left. So I am writing directly 12 OH minus and get cancelled there plus 6 Cl2 and giving what? 10 Cl minus plus 2 ClO3 minus plus here 12 H2O, 6 water get cancelled, rest how much? 6 water molecules are left. And what is the medium here? So this is the basic medium and this is the balancing redox reaction of, I mean disproportionation reaction of chlorine in basic medium. After doing this one again we have to balance them and check that charge neutrality, number of atom neutrality. So what is the charge here? 12 minus 12 charge is there. Here what is that? 0. And here this is the minus 10 charge. Here 1 ion minus 1. So 2 ions means minus 2 charge. Left side minus 12 charge. Right side also minus 12 charge. Charge neutrality is there. Next one. Number of chlorine atoms 12. 10 plus 2. 12 chlorine atoms. Next one. Oxygen atoms 12. Oxygen atoms here 6. And 2, 3, 6. Hydrogen atoms 12 and here hydrogen atoms are 12. So everything is balanced and this is the disproportionation balancing equation of chlorine in basic medium. So next another one, this is very important because many students may get confused here. How to do this one I will tell you. The next balancing equation is balancing of polyatomic molecule containing redox reaction. Polyatomic molecule, suppose P4 and converts into phosphine plus H2PO2 minus ion. So balance this equation in basic medium. So this is what polyatomic molecule P4 or another polyatomic molecule S8 sulfur, S8 chrome structure. So these kind of equations what we have to do here. So just important trick, remember here, we should not write P4 or polyatomic molecule here. We should write only single atom. It's to be considered as a single atom, only phosphorus atom. If we take acid redox reaction, we have to take only sulfur, single sulfur atom. Here also only we have to consider phosphorus atom, single phosphorus atom. Then you make it very easily. That's the important trick. So I am writing here P, only single phosphorus atom to PH3, one reaction. Next here only phosphorus atom to H2PO2 minus reaction. And this is our trick. Okay, so remember here we should not write P4, we have to write only, it's to be considered as a single atom, phosphorus. Now here only one phosphorus atom, here also only one phosphorus atom, so it's to be already balanced. Now next one is what? X equals to 0, here X equals to what is the charge? Minus 3 charge. So electrons to be added to the higher oxidation side. So what is this reaction? Addition of electrons, reduction reaction. Whereas here X equals to only here one phosphorus atom, here also one phosphorus atom. So X equals to 0. Now here X equals to, so what is the equation? plus 2 for hydrogens, and we are going to find the oxidation state of phosphorus considered to be H, and minus 4 equals to minus 1. So from this equation, what is the X value? X value equals to plus 1. So number of electrons difference is 1 added to the higher oxidation side. So this reaction, addition of electrons, that's why it's reduction reaction, and this reaction, removal of electrons, that's why it is oxidation reaction. So after doing this, here we have to balance the number of oxygen atoms by adding water molecules, but there is no further oxygen atoms are there, but hydrogen atoms are there. So we have to balance that hydrogen atoms by adding H plus ions. So left side we don't have any hydrogen atom, but right side we have 3 hydrogen atoms, that's why. So left side 3 H plus to be added, and rest as it is equation 3 electrons plus 1 phosphorus atom and giving pH3. So this is the first equation, because there is no further addition of oxygen atoms, only hydrogen atoms to be balanced. And here, so how many hydrogen atoms are there? 2. How many oxygen atoms are there? So first we have to balance the oxygen atoms by adding water molecules. How many oxygen atoms? 2 are there, that's why. So 2H2O plus phosphorus and giving H2PO2 minus plus 1 electron. After balancing number of oxygen atoms, we have to balance the number of hydrogen atoms by adding H plus ions. So left side how many hydrogens? 4 hydrogen. Right side how many hydrogens? Only 2 hydrogens. So rest 2 hydrogens to be balanced by 2 H plus ions. Now after doing this one, the last one is balance the number of electrons on both sides. Here how many electrons are there? 3. Here how many electrons are there? Only 1. If this reaction, this equation is multiplied by 3, then we can get equal number of electrons on both sides. So first equation is the as it is equation. First equation is 3H plus 3 electrons plus phosphorus and giving phosphine. Next, second equation is multiplied by 3, then we can get 3 electrons. So equation multiplied by 3 means 6 water molecules plus 3 phosphorus and giving 3H2PO2 minus plus 3 electrons plus 6 H plus ions plus 6 H plus ions. So 3 electrons get cancelled. Now, so rest is what? 3H plus. So here 3H plus, here also 6H plus is there. Okay, you can remove this 3 also, and from here 3 and rest 3 are there. So overall is 6 water molecule plus, and this is very important. So what is the total? 4P, and next 1 phosphine plus 3 moles of H2PO2 minus, and plus here 3 hydrogens are to be cancelled, and rest of 3 H plus ions are there. Right, and what is the medium of this one? Medium of this one is acidic medium. So, but the question is about in basic medium. So, same 3 OH minus, and here also 3 OH minus are to be added on both sides. So, 3H plus 3 OH minus, and forming 3 molecules of water. 3 water molecule get cancelled, and we are getting this side 3 water molecules are left. So overall 3 OH minus plus, here only 3 water molecules are there, and plus, so this is very important. And actually what is a molecule? Polyatomic P4 molecule, and we are considered as a single atom, phosphorus, but in actually this balancing equation is about polyatomic P4 molecule, and we are getting what is P4P. This 4P we have to write as P4. It means not 4 single phosphorus atoms, 1 molecule of P4, that we have to do here. This is very important thing. If you do P4 individually, it's very, it seems to be very difficult calci, because we have to, here if it is P4 and we have to balance the 4, here also if you take P4 and phosphorus atom balancing 4, and we make it lengthy calci. That's why I gave this shortcut. So it's to be considered as single atom only, but in the final equation we should maintain the same number of atoms. If it is P4 atoms, in the final equation we should get the same number of atoms. If in the final equation if we get 2P here, After doing this final equation, that final equation should be multiplied by 2. Then 2 into 2p becomes 4p. That 4p is modified as p4 molecule. That's very important here. Okay, I am writing here p4, and p4 giving what? The next 1 phosphine atom plus 3 moles of H2PO2 minus, and here 3H plus, this get cancelled each other. Now we are getting, this is the redox balancing equation for the given chemical reaction. So the redox reaction, balanced redox reaction of polyatomic molecule. Again, after doing this, we have to check that. So charge -3, 0, 0. Left side we have overall charge is -3, and here 0, this one single ion. So 3 moles are there, -3, -3 balance. And phosphorus 4 atoms, 1 phosphorus, 3 phosphorus, 4 phosphorus atoms. Next one oxygens, 3 oxygens, here 3 oxygens, 6 oxygens. So O2 into 3, 6 oxygen atoms. Hydrogen, here 3, here 6, 9 hydrogens. Here 6 and here 3, 9 hydrogens. So everything is balanced. And this is about balancing a redox reaction which contains polyatomic molecule. I told you this is very, very important. If any polyatomic molecule is there, it's to be considered as a single atom initially, but in the final equation we should maintain the same number of atoms. So here P4 is there, we should maintain same 4 phosphorus atoms. After that it should be modified into single P4 molecule, right? So let's see with another example, polyatomic example. So balance the disproportionation reaction of S8. So S8 and giving sulfide ion plus thiosulfate and balance this equation in basic medium. Balance this equation in basic medium, and this is the polyatomic molecule. So 0 to what are the oxidations? And here first sulfur oxidation state is 0. Here sulfur oxidation state is -2. Here 2x minus 6 equals to -2. Then 2x equals to plus 4. So x equals to plus 2 you may get here, right? Yes or no? Here 2x. So 2x minus 6 equals to -2. Then 2x equals to plus 4. So x equals to plus 2. 0 to -2 addition of electrons, 0 to +2 removal of electrons. So we have to write separately. But again I told you, if it is a polyatomic molecule, it should be considered as a single atom. So sulfur atom to sulfide ion one reaction, sulfur atom to thiosulfate one reaction, right? And here x only one single atom is there. So x equals to 0. Here x equals to -2. Electrons difference are 2, so that electrons will be added to higher oxidation or higher oxidation positive side. So what is the reaction? Addition of electron, reduction reaction. And here 2 sulfur atoms, here we have only 1 sulfur atom, so it should be balanced. Next point, so what is this 2x? It's only single atom, so single atom oxidation state is 0, because of course it is a polyatomic. In this polyatomic, oxidation states of 8 sulfurs are 0 only. And P4 oxidation state, each phosphorus atom oxidation state is 0 only. That's why we are taking single atom 0, single atom 0. So if it is 0 and 2x equals to also 0, but here 2x equals to plus 4. I told you already, whatever the number of atoms are there, we should maintain the same number of atoms. The difference is 4 electrons, and that 4 electrons to be added to the higher oxidation side. And there are no other balancing oxygen atoms or hydrogen atoms, but here is that. So how many oxygen atoms are there at right side? 3 oxygen atoms. That's why we have to add 3 water molecule plus 2 sulfur and giving S2O3 minus 2 plus 4 electrons. After doing this one, so balance the number of hydrogen atoms. 6 hydrogen atoms are there. That's why 6H plus to be added to the opposite direction of water molecules. After doing this, we have to balance the number of electrons. Here 4 electrons in oxidation reaction, but we have only 2 electrons in the reduction reaction. So if it is the first equation, this is the second equation. So equation 1 into, to maintain 4 electrons, equation 1 into 2. Then what is the equation? 4 electrons plus 2 sulfur atoms and giving 2 sulfide ions. Now the second equation is as it is. Second equation is as it is. So 3 water molecules plus 2s giving S2O3 2 minus plus 4 electrons and plus last one is 6H plus ions. So balance this equation, 4 electrons, 4 electrons. So resultant one is 3 water molecules plus 2s, 2s, 4s and giving 2 sulfide plus 1 thiosulfate plus 6H plus ions. And what is this? Balancing equation in acidic medium, but this is not the exactly balanced equation because S8 polyatomic molecule contains 8 sulfur atoms, but in the last equation we got only 4 sulfur atoms. I told you in the last equation, if we should maintain the same number of atoms, then only you can write the same number of atom equals to 1 polyatomic molecule. So this equation should be multiplied by 2, then we can get 6 water molecules plus 8 sulfur atoms. That 8 sulfur atoms you can write the polyatomic S8 molecule and giving here 4 sulfide plus 2 thiosulfate plus 12H plus ions, and this is the S8 is there. So in his which medium it is? Acidic medium, and this is the acidic medium. So but the question is about basic medium. Are you getting my point here? This is only 4 sulfur atoms are there. What we got here? 4 sulfur atoms balancing equation, but polyatomic sulfur contains 8 sulfur atoms, so we have to maintain the same number of atoms here. That's why the final equation is multiplied by 2, then we can get 2 into 4 is 8s. That 8 sulfur atoms can be modified as 1 molecule of S8 because S8 is our reactant, given reactant. But it is, what is the medium? Only acidic medium, but the question is about basic medium. So same number of hydroxide would be added on both sides. Same number of hydroxide would be added on both sides. So resultant one is what? 12 OH minus. Here 12 water molecules, 6 water molecules. So 6 get cancelled and result in at right side we are getting 6 water molecules. We have to write that one. And S8 is as it is. Now here 4 sulfide ion plus 2 moles of thiosulfate ion, and here 12 water molecules. From here 6 get cancelled, and rest how many water molecules are there? 6 water molecules are there, and this is a polyatomic S8 balancing equation in basic medium. Again after doing this we have to check. So sulfur, how many atoms? S8. Here sulfur atoms, 4 sulfur atoms and 4 sulfur atoms, 8 atoms, and oxygen atoms at left side 12. Oxygen here 2 into 3 6 and 6 into 1 12. And here 12 hydrogen atoms, here also 12 hydrogen atoms. So charge neutrality, this is 0, and what is the left side charge? Minus 12. Here what is the charge? 4 into minus 2 minus 8, and 2 into minus 2 minus 4, and this is 0 of course. So both side charge neutrality is there. So charge neutrality, and all atoms would be maintained the same number of atoms on both sides. So this is about the balancing redox reaction or disproportionation reaction of polyatomic molecule. Very important trick here. Whatever the polyatomic molecule is there, it's to be considered as single atom, but in the final equation we should maintain the same number of atoms. Then you can get our resultant equation. So this is all about balancing a redox reaction. Hope you can get. So thank you for watching.